Hey, hello and welcome back to the 2023 CCSE Research Conference, Politics, Communication, and Polarization, hosted by the Center for C-SPAN Scholarship and Engagement and the Brian Lamb School of Communication at Purdue University. I'm Andrea Langrish, Managing Director of the Center for C-SPAN Scholarship and Engagement. Before we get started, please be sure your camera is turned on so our speakers can see you and your microphone is on mute. You will use the raise hand function during the Q&A portion of the session. Introducing our guest today is Dr. Robert Browning, Professor of Political Science and Communication at Purdue University and Faculty Director for the Center for C-SPAN Scholarship and Engagement. Dr. Browning.
Okay, good afternoon. This talk coming up outlines the vision for the CCSE Presidential Debate Archive and Data Co-op, hosted by the CCSE here at Purdue. Embracing the open science framework, the Data Co-op would make a detailed verbal and nonverbal coding of candidate behavior during debates available for use in training sets for researchers interested in conducting large-scale computational analysis of presidential debates. Our guests today are Erik Bucy of Marshall and Charlene Formby, Regents Professor of Strategic Communication at Texas Tech. That's a mouthful. He holds a Ph.D. in Mass Comm from the University of Maryland, College Park. His research interests encompass visual and nonverbal analysis of news and politics, user engagement with media technologies, and normative theories of democracy and media. His work has been featured in leading journals in communication, information technology. He's co-authored an award-winning book, Image Bite Politics, News and Visual Framing of Elections, and has also served as editor of Politics and Life Sciences. He's also joined by Dhavan Shah, whose PhD from the University of Minnesota is in McLeod, sorry. And letters didn't work for me. McLeod Professor of Communication Research and the Meyer Bascom Chair in the School of Journalism and Mass Comm at the University of Wisconsin-Madison, where he's the director of the Mass Comm Research Center and the research director of the Center for Communication and Civic Renewal. His focus on the intersecting power of framing and social capital has shaped his research, the influence of message construction and processing, the communication dynamics shaping civic and political participation, and the role of online interactions in chronic disease management. Welcome, Erik and Dhavan. I'm going to turn it over to you to do your presentation and hope we have some time for questions.
Great, thanks. And just to clarify, how much time do we have?
What do we have? We have up until 2 o'clock.
Oh, okay.
We only have about a half hour.
Oh, okay, great. And do I have screen sharing? Or if I click on my presentation, can you see it?
Why don't you try?
Okay, so I did.
Andrea?
So Erik and Dhavan, both of you have co-hosting capabilities, so you should see on your Zoom bar share screen.
Okay. Okay, how about now?
Yeah, good. Let me see the screens.
Okay, great. So I'll advance the slides, but this is probably going to be very back and forth between me and Dhavan. We think alike on these matters, but there's some strong suits that both of us have. So let me just open it, and then with the very next slide, I'm going to kick it to Dhavan. But this is an idea, Robert, as you mentioned, that we kind of articulated last year in a book chapter for the Year in C-SPAN Archives research. And we also did a demonstration of the way that our presidential debate data can be used and even modeled computationally. And that kind of gives impetus to this idea, which is, it kind of comes out of an open science framework and is happening a lot in data science and computational areas, where there'll be large data sets, and they can be images, they can be text, they can be multimodal video, or even things like tweets or individual images. And the research community in the computational areas make these data sets freely available, so anybody can download them and find patterns demonstrate processes and really find evidence for theories. We haven't really done this in the area of political communication, but this is really, I think, a golden opportunity to try it out on, kind of a small scale through the C-SPAN archives. And we've been doing so much work in debates and analyzing, kind of this television footage and then pairing it with social media data that it does seem like a really good time to think about this seriously. So what are data co-ops? Just very generally, they're repositories for the pooling and storage of data. Usually it's done on a voluntary basis. You don't ask for money or any kind of revenue associated with it. And it's intended to make research, not only the data, but sometimes the tools, for instance, programs or open source software or codes that you might use in algorithms, available to the broadest range of qualified investigators. So it's really about opening up the research space and advancing what you can do, on a faster pace and on a larger scale than just individually on your own. And in lieu of any kind of revenue attached to this, usually what happens is the people who host the platform are just included as a trailing author. So that's all we're thinking about. I just pulled an image of open science, but it's it's a big trend, even in social science, but across psychology and other disciplines that are having a hard time with replication. So, but part of that is it's not just a replication crisis, it's also this tendency towards open access of journals, of data, of making things shareable and usable. Okay, now Dhavan, I'm going to kick it to you for kind of the concept of the co-op.
Sure. So, we have to date looked at. Erik and I call it our Reese's peanut butter cup moment. For the older people in the room, you'll remember those old Reese's ads where someone's walking around with a jar of peanut butter open, which I don't know why people did in the 70s, and then someone's got some chocolate bar and they trip over each other and one lands in the other. Erik and I were I was visiting Texas Tech and giving a talk about some computational analysis we were doing of debate responses. And Erik mentioned he had all this coded data of what candidates did during debates. And we thought, well, could we put these two things together? And really the raw data and the manual coding that's kind of laid out here started with that set of coded insights. So Erik having coded data on exactly, moment by moment, looking, I think, starting at 30-second increments, and I think we've gone down to 10-second increments now, looking at what candidates, the images are that are being conveyed during those debates. What are their gestures? What are their facial expressions? What is their gaze? What is their blink rate? The kind of detail that's been available in that raw data that you can manually code is quite tremendous. We also have an audio layer, obviously, the tone of voice, how candidates sound and what they how they enunciate their words, how clear they are, what their cadence is, their pitch. Are they elevated and extreme, or are they calm and reassuring? Those kinds of elements. And then obviously there's the text layer, and those are debate transcripts. Being able to take the images and the video, being able to take those audio files and those debate transcripts and codify them in different ways, that raw data exists within C-SPAN videos, right? That's the raw material that's already there that you've been collecting and have available for years. And in fact, C-SPAN videos are what we've often used for our coding purposes because they're the best, oftentimes split screen shots. They don't add a lot of unnecessary drama. They're just straight shots of the candidates. And so for training a computer vision analyzer, those are fantastic. They're still shots. They're not shifting around the camera angle. They're not going for dramatic close-ups. They're holding things in a fixed, array. So we can do things like gestural capture. We can do facial telemetry, tone of voice, the verbal cues. Then we can match the text. We can match up with that, and we can build what are called different kinds of multimodal classifiers. And I know we're going to get into this a little bit more potentially later on in this conversation, but the idea here is the ability to take a lot of the manual coding and using computer vision techniques, using, different computer audio techniques, and then natural language processing techniques, turning that into coded material that can be shared in an open science framework. So I know we don't have a lot of time and a lot of slides, Erik, so I'll toss it back to you, but I hope that gives a general sense of how we could take not just one debate's worth of data, but literally, and I think the next slide, if Erik clicks forward to it, every debate since 1976 forward, and start to really analyze them systematically, put them through formal visual classification using computer vision, put them through tonal classification, put them through text classification, and then put all that data up and make it usable. Now, the ability to match it with social media is a whole additional layer, which I think we'll get into next, but I'll toss it back to Erik.
Yeah, just real quick. Number one, most debate and a lot of political communication research isn't longitudinal. So we kind of deliberately went into this space to try to show some over time, trends and changes. And we did find significant change when you get into the Trump era, although it's not real apparent here, but it's real apparent in the data. And there's an era of polite politics, which is before Trump, and there's an era of Trump that the classifier identifies. But when you look at images, just real briefly, it looks like a bunch of noise or a bunch of trivial kind of screen captures, but really you're seeing a lot of rich communication happen here, even non-verbally, even in the still images. You see facial expressions, you see gestures, you see pointing, you see kind of affinity displays where there's obvious kind of mirth going on and laughter. You see some harder edge, real point making, and you see visual references to the other candidate. There's a lot of information here. So the body's in play, the face is in play, the hands and torso. There's a lot that you can do with this to code. So that gets us to training data. Just briefly, we treat images basically as reliable sources of information. Now, no one would question the scientific kind of validity of the top image, but the bottom panel, you wonder. But then you look very closely and you have to ask, is that a fly on Mike Pence's head? And was that during the vice presidential debate? And yes, that actually happened. I'm not saying that's consequential, but it's unusual. And so people notice it. They pick up on it, and they pick up on facial expressions, gestures, and other nonverbal signals that really communicate not just emotion, but intention. And of course, we go back to kind of Ronald Reagan, and he was considered a great communicator for some reason, because he could kind of barrel through any of the criticism and kind of maintain, a likability and a deniability that other candidates haven't had. So here you see the kind of fundamental categories we work with in terms of facial expressions, and there's the emotion at the beginning here that's expressed, and then the intention with the second term. So it's not just anger, it's communicating threat. It's not just happiness, it's communicating reassurance. And it's not just fear, and that's pretty rare in a politician, but there might be kind of a pulling back or an evasion, and that is communicating they want to get out of the space and get away from the question. And there's reasons in the biobehavior literature why these are significant displays, and they either encourage bonding and promote that, or among followers. And you could see this with Trump now and other kind of populist candidates, that a threat display or an attack actually promotes bonding, but among followers, not among critics or not among nonpartisans. So you get a nuanced kind of rationale there for the different kinds of displays. Now, you start to code this and you end up with training data. Just real quickly, we don't just kind of do this by gestalt or by hunch. We actually have categories, and it relates to a lot of different features of the face, in addition to motion in the head, and then even the orientation towards the trunk or side to side. And it becomes very clear that these are distinct expressions. Now we code them as either being present or absent, so it's 0 or 1. So it's not a real nuanced thing, and we can get high reliability. So based on that, you can start to see with different candidates, you get prototypical displays. This is clearly a smile, and it's an engaged smile, and it's seen as genuine because there's a softening of the eyes, and where in a plastic smile or a forced smile, there's kind of a lack of synchrony between the mouth and the eyes. You get neutral. It's a little bit hard to code because it also looks a little bit like slightly negative. But when you get to anger, there's something going on with the teeth, and usually you see a lower display of teeth. I know that sounds funny, but think about when you smile, and here it is with Obama, you see the upper row, and when you frown, you're more likely to see the lower row. And when there's evasion, you tend to look down, and if you look at that head orientation, it's cocked to the, let's see, that would be his right, and he's looking down. So you can see these displays, and they may vary by candidate, but there's the lower teeth, there's the upper teeth looking down, and kind of neutral there. Also with an anger display, there's a fixed stare, like you're focusing in on a target. So the eyes really come into play. All right, now what can you do with this stuff? Well, you can play around with it in charts, and it's really kind of fun. So once you start to tally it up, you get these descriptive data, and these are really serve as the training data for the classifier. So I don't want to spend too much time on this, but here you've got, I think, the 2012 debates, and you've got a big problem with Obama looking down. So we tracked that in terms of evasion, and he kept looking down at the podium at his notes. Well, was that more than Romney? Yes, it was twice as much. So it really bothered people, but it also was really present. And here Romney's much more on the aggressive. He's communicating a lot more defiance, which is kind of like raised fist or pointed finger. Now, what happens when you get to debate 3? Whoa, it goes away. So Obama learned, somebody talked to him. They said, don't look down, stay engaged with your opponent. And suddenly you see more aggression coming out of Obama, at least nonverbal, kind of visual. I'm going to hold you account kind of aggression, not the level that you would see it with Trump. But with Trump, here we are in 2016, and you can see just so Trump's in the red bars, and you can see just the percent of occurrence of different, kind of aggression displays. So it's either anger, threat, or it's a defiance gesture, or it's even a voice tone. And he's just way beyond anything that Clinton's doing. And that's debate 1. And then you can see it persists into debate 3, although she starts to bring a negative voice tone in there. Let's see. Okay, and then we normed it to say, well, is it unfair from a gendered point of view to compare Trump to Clinton, because women have almost like a higher hurdle to kind of overcome when it comes to debates, and finding a delicate balance between being poised but being assertive. And they really are penalized, as the gender stereotypes literature points out again and again, if they're seen as going on the attack. But when we normed it to Trump to 2 other male candidates, he's way more expressive. This is interesting kind of preliminary findings just from our descriptive data, and you see it debate 1 and debate 3. And you do see an interesting change with Clinton. She does get more expressive between debate 1 and 3 of 2016, but again, it's nothing in comparison to Trump. We're going to see later how this moves some of our variables in a time series regression model. And then Trump stays more or less the same, but shows a little more anger in the first debate going back to 2016. Okay, so we now get to an application of this. That was descriptive data, what you get from just coding using some of those categories that we use. And another thing we can post in the data co-op is our code books and our definitions, so everybody knows what they're coding if they want to go back in and do additional data collection and then post it to the co-op. So here I want to turn it back over to Dhavan and talk about the whole kind of pairing now of our debate data with the social media data.
Right. So, thorny question that's been at the center of studying debates that Robert and others, I'm sure, will recall, goes back to the initial Nixon-Kennedy debates. Does it matter how a candidate appears, or is it what they say, right? People who listened to Kennedy, Nixon on the radio supposedly had a different reaction to it than those who saw the televised debate. One of the things we've been able to do as a kind of modern twist on that is to be able to try to peel apart the different layers of the debate experience. Is it the visual experience? Is it the oral kind of layer, the audio, or is it the text that's producing a particular kind of response among the audience? And to do that, we're looking at pairing what's happening on the debate screen with what's happening in the social media response. It's essentially pairing the first screen with the second screen. And many people now will consume media with their computer or their phone open. And so the ability to synchronize Twitter responses with our debate coding allows us to say, okay, what's happening on the debate at a particular moment? Is it a certain kind of gesture? Is it a certain facial grimace or expression? Is it a tone of voice or a change in pitch? Is it instead what they said? Is it a particular attack or blame or talking about a particular issue? What is it that is driving the social media response? And then we're able to test this at different lags. So we test it at shorter and longer lags. In the most recent studies, we've done this at 10-second increments, and we've coded about 530 to 540 codable segments. Mm-hmm. We have these double coded for reliability. We're coding for a whole host of features, right? And so again, things like happiness, reassurance, anger, threat. We have all the tone, voice tone. We have gestures. We also code for mimetic moments, which are kind of, again, moments unexpectedly. In the Obama-Romney debate, you were just kind of being shown images of. We remember the Big Bird moment, for example. Communal or agentic style, different kinds of verbal tics, including verbal non-fluencies, blink rate. So all of this can be coded and then paired with data we purchased from GNIP. So this was, for the first debate, it was 5 million tweets over that 90-minute period. For the third debate, it was 3 million. We didn't do the second debate because that's more of the town hall style. We prefer that straight shot for our ability to code in a very kind of equivalent manner. The volume of responsiveness, you can see how much it varies in terms of mentions of the particular candidates. And we can also do things like the valence or affect directed at those candidates in those tweets. So not just how much attention are they getting, though we're in an attention economy and that's our primary concern, but also what is the kind of reaction that they're producing? Is it a positive or negative reaction? You can keep going. Mm-hmm. One of the things we were able to do then is by taking these different layers, the visual, the tonal, and the verbal, and looking at the responsiveness of social media to those different layers, is we're able to show that Trump's use of visuals, in particular, this very bombastic, kind of aggressive, we call it a transgressive style, almost a populist style, it's very bombastic, was able to drive the social media response within 10 seconds. And it lasted for almost 60 seconds. So those are 10-second increments out. And you're seeing that visual kind of index is the one that's driving it. Tonal and verbal elements mattered at about 40 seconds. People had to process those. It took a little bit longer, did have an impact. If you compare this to Clinton, which I think is the next slide.
Yep, there we are.
Is one of the things you notice is, for starters, she's just not having the same visual impact. And when she's having it, it's at a much longer lag. Her way of making an impact is more verbal. And yet, as we know from most kinds of responses, if we're reacting to something verbally, it takes us a while to compose a response, versus when we see something visually, we can shoot off something really quickly. Again, it's that the power of visuals, and it's part of that image bank politics work that Erik has done. And so here we see a much slower rate of response. That populist visual and verbal style drove the response, and it allowed Trump to dominate the social media discourse. And again, in an attention economy framework, thinking about how these different ways of, not just the visual elements, but also the verbal rejoinders and other attempts at, interruption, how all of these factors play into driving what is the kind of response, what is the immediate online spin room that is the debate now, which happens now on social media, is something that we really have explored. We've also looked at the kind of elite layer of this too. I'll throw it back to you, Erik. I don't know if you want to handle this next part, if you want me to handle it.
Yeah, just real quick, I'll introduce it and then you can carry it through, but I see we're almost running out of time already. So real briefly, computation has now burst onto the scene through computer vision techniques that were developed kind of in the 2010s, but really in the last 5 years have come into their own in political communication research. And Bryce, who's with us right now, is one of the leaders in this area. So it's amazing. I did a kind of a review article just to see where things were at with political communication. I called it Politics Through Machine Eyes. And there really is a range of things being studied now. You can see at the bottom here. The topics are broad ranging, and the journals and disciplines are traversing everything from political common data science to digital humanities and semiotics. So a lot of people are getting into the space, and it gives the co-op idea some momentum, a rationale, and some force. Like the timing is really good with this. When you start to use computer techniques, they're not coding at 10 seconds, they're coding moment by moment. And the machine's able to basically disassemble the video from a moving sense to a series of individual stills that it can then pinpoint what is exactly happening with the expression in any given moment in time, rather than within a 10-second segment of time. Let me go forward just a little bit, and here Dhavan can come back in and kind of describe this.
Yeah, I'll just close it up here. What we're moving towards now is what's called multimodal modeling of debates, which is to do computer vision using different kinds of computer algorithms for getting at the tonal layer, and then doing natural language processing of the textual layer of the data, using all of that data, feeding it to algorithms to produce the end text. If you want to click forward, that really what we're doing is taking the audio sequence, the video sequence, and the text sequence, and really treating these two different audio and video sequence and the text vector as this kind of hidden layer, and using it to produce a multimodal vector classifier. And in this process, if you can click to the next slide, this is a little more detailed version of what this looks like. But maybe the important part to kind of consider is on the tail end of this, which is we emphasize the text and what's being said over the audio and the video. And that's, again, because these are debates, and we think what's being said obviously has a great deal of relevance. So we understand those high intensity moments, partly through what's being said, and then how it's being amplified through audio or amplified through video. So these are the hidden correlations we're considering. If you want to go to the next slide.
Mm-hmm.
And so essentially it's, looking at something like if someone said, oh, I just finished watching this new movie, and they lowered their voice, having those three elements together, their downcast gaze, having that lowered voice, is what lets us do that classification. It's those three layers together, but it's understanding they're talking about the movie, this is what they're evaluating, the image and that in combination both feed into the classification. Last slide. And so this is what we're doing with debates now, and what we could do at much larger scale if there was a C-SPAN archive.
And then I think, let's just go through this, but real quickly, you can see that we take some of the descriptives, and here we're sampling, we're taking 20% of each first debate from 1980 to 2020, and we're asking, essentially, has aggression increased? And if so, has it done it in a linear fashion? Has it done it some other fashion? And what's the difference between the earlier debates versus the later debates? And then we use a classifier to kind of group or detect the different features that we've been coding for. And here, Dhavan, you can describe this chart here.
Yeah. So one of the things we discovered, and I think of that chart that Erik just showed kind of amplifies this, which is the rules changed in 2016. Donald Trump, hyper-aggressive style, showed in the charts that Erik shared earlier. When we built our classification model, we had to build a two-part model. We had to do data, if we tried to do it with all data, it didn't perform. If we split the data from 2016 and 2020 and separated from the the prior to 2016 data, we could get much better model performance. So we ended up building a kind of twofold classifier, taking advantage of that distinction. In doing that, we're able to now produce a multimodal classifier of aggression in political debates that we could apply across a range of debates.
Right, and this is detailed in that chapter, but also in a recent article just came out. It's online in Communication Methods and Measures. So we introduce that as kind of a technique that other people can use as well, which is part of the computational strain. So anyway, creating the co-op would basically, it would have to start with a series of discussions. We all want to get on the same page, and we want to have a dedicated page online for this. We would upload debates. We could upload training data, that 20% of each first debate, but maybe also coding for entire debates since we have it, and continue to feed into that. We could have our code books, and we have other elements here, which could be, suggested models. It could be software syntax or coding syntax. It could be, not that we control it, but social media data, or at least the searches that we did to get the same kind of data. Dhavan, you could describe that for a second.
Yeah, so, in terms of our social media content, we're currently retrieving it via a system called Synthesio. It allows us to take things like tweet IDs and make them available. And from that, you can then rehydrate the data to produce the full metadata. There are now techniques that we can do that. The Twitter API has been shut off by Twitter, now X, and so that's not as readily available, though there are commercial providers, and some now are emerging that are making it more affordable to rehydrate that data at the level we're talking about for debates. So something that if we were to make this more open science, even that social media data could be shareable in some forms.
Right. And then just to wrap up quickly. So why do this? Well, number one, it improves the larger project of trying to perfect these models, of gain efficiency, of making them more accurate, of being able to identify what the patterns in discourse, visual kind of symbolism and visual signs, as well as the nonverbal behaviors. And so it really advances the scientific project. And it opens it up to teams of researchers rather than individual groups like ours doing this, what we can do on our own kind of limited resources. The more you can open this up, the bigger and faster it grows. It's a one-stop shop for research. It will help reduce duplication, so people know that there's activity going on here. This is the place to do computational research of debates. Can become very popular internationally. It could benefit early career and unfunded researchers everywhere who just want to pull it down. And it could also foster a more inclusive and democratic environment because it would be open. And so if you're a researcher, the way I've seen this at some data co-ops or some data repositories, you just write from your university account and you have a short application. You say what you want to use the data for, and you granted access, but then you know who's using the data. So it lowers costs and it reduces barriers to entry, and then allows researchers to make even greater use of the C-SPAN archives. I think we're out of time.
Yeah, I'll just close one little last comment to add to what Erik said, and that is, if you open this up and you invite computational researchers in, I think there'd be great interest in this, partly because they love benchmarking. They love being able to take work and then being able to compare and improve. And that whole ability to do it within a stable data set like the C-SPAN archive would be, I think, just a gold mine for computational and especially computer vision researchers. So thank you very much.
Mm-hmm.
I think, thank you both. The great presentation shows the richness of what you have. I think the next step is to sort of get an outline of how much data you have, what the elements of each one are, think about how to organize it, and then set some benchmarks or goals of having some data in there that we can sort of demonstrate how it would work.
Mm-hmm.
So why don't we, if we can follow up, Erik and Dhavan, with meeting of you and I and
Bryce.
Bryce, and we can sort of outline those steps and sort of see if we can't get some data in there in
That'd be
some
great.
form of organization. Bryce, you want to add anything before we
Yeah,
sign off?
so yeah, we can certainly have further conversations about this. So like the first thing that immediately comes to mind is Social Science 1, which is kind of a data co-op centered around Facebook and other types of data. So the value for a co-op in that format is that when you have proprietary data, like C-SPAN's data, is having some sort of organization that sits on top of that and manages access to the data is helpful because it gives companies like C-SPAN or Facebook or whatever reassurances that their data is not just being posted on like
That's
a
right.
server and any Joe Schmo can just download it. And for a company like Facebook, the problem would be, oh, we used the Facebook data, and lo and behold, we found out that there's a bunch of racist people on Facebook, and then they get this bad publicity related to the data set. So the Social Science 1 infrastructure is meant to sit on top of that to give a little institutional protection for those companies with respect to the use of their data, gives a little IP protection. It's part of more of the academic environment, so forth and so on. So the reason why that is relevant for this discussion is that, so Jake Truscott, who's on the call, he is the inaugural C-SPAN CCSE postdoc. And so what Jake and I have been working on is creating a large collection of floor speeches. Robert and I and others are interested in potentially making this more widely available. But the challenge is that, you can't just hand over a bunch of floor speeches, because of its proprietary data. There's also just like, how do you handle gigabytes and gigabytes of data? And so having some sort of infrastructure that sits upon that, as well as presidential debates within that same environment, I think could be potentially useful as we try to expand access. So yeah, I think that sounds interesting to me, for sure. And we can have more conversations. And yes, congratulations. I believe Joyce Jang is, I assume, part of your team, because she also did multimodal classification of presidential debates yesterday. And so she was, I think, part of the UCLA folks. And so congratulations on all the great stuff that you all are doing, because it all seems very interesting to me.
Great. Good to see you. Bye,
All
everybody.
right. Very
Gotta
good.
run.
Thanks so much for joining us.
Thank you. Bye-bye now.